initial estimate for each bus V3 and V2, okay, from the reference bus. So given in this example, V2 0 equal to 1 plus J0, which is 1 with the angle 0, while for V3 0 initial value equal to 1.04 plus J 0.0 or 1.04 angle 0 degree. This already stated in this statement. It says that the voltage magnitude at bus 3 is fixed at 1.04. Okay, so V3 you should fix to 1.04. Only thing for initial value V2 and V3 should be 1 with the angle 0. Okay, start with 1 angle 0 for V2. Okay, and you can start doing your first iteration. Okay, we start look at bus 2. So bus 2 with V iterations equal to P2 schedule minus JQ2 schedule divided by V2 conjugate using initial value. Then plus Y12 times V1 plus Y23 times V3 initial value. Then this have to divided by Y12 plus Y23. Okay, your diagonal elements. Okay, so put back all the value including the power that you already convert into per unit here. So you find that the value is 0.97462 minus J 0.042307. This is in per unit. Okay, it has 5 decimal places. Then we move to V3, but in V3 we know that this is PV bus. So PV bus, you have only P, you don't have Q. So therefore we have to estimate the Q value. Okay, so Q31 is equal to minus imaginary for V3 conjugate for initial value times V30 times Y13 plus Y23. So this is a diagonal elements minus Y13 times V1 minus Y23 times V2 for your first iterations. So this V21 is the one that you already calculated before, which is this one. So use back this value, put into these equations and others like V30 and all the admittances. So finally, you will find that the value is 2 minus 2.3919 plus 1.15985. So you have real part and the imaginary part. Okay. So in this case, you have real and imaginary part. For Q3, you only need to look into the imaginary part. So in this case, it is 1.16. So 1.16. So the value of Q3 first iteration is used as Q3 schedule. So for the computation of voltage at bus 3, the complex voltage at bus 3 denoted by VC3. Okay, the complex voltage at bus 3 is denoted by VC. C stands for complex, 3 for the first iteration. So you can start calculate for VC3. So VC3 first iterations is equal to P3 schedules. This will be fixed because P3 given 200 megawatts. So you already change into 2 megawatt, 2 per unit, and minus JQ2 SCH. Oh, sorry, minus JQ3 SCH. So this minus JQ3 SCH, the one at you calculated here. So put into this part later on. Then divided by V3 conjugate 0 plus Y13 V1 plus Y23 V2. Okay, V2 first iteration. So first iterations, the one that you already got it here, put into this term. Okay, then all this you have to divide it by your diagonal element, which is Y13 plus Y23. So you got all the parameters. put it and do the calculations. So finally, we find that VC31 equal to 1.03783 minus J 0.0517. Since we know that VC3, we have the fixed value for the real part, which is 1.04. So we only use the imaginary part later on. So only the imaginary part of VC31 is retained. For example, F31 equal to minus 0.0517. Therefore, the real part is obtained from, so E31 equal to square root 1.04 square minus 0.05 0.00517 square. So you find that it is 1.039987. So your V3 first iteration is equal to 1.039987 minus J 0.0517. Okay, done for first iterations. So now move to second iteration. So second iteration, you do again the same step for bus number 2. Okay, bus number 2, second iteration equal to P2 schedule minus JQ schedule divided by V2 conjugate for first iteration plus Y12 times V1 plus Y23 V3 first iterations and divided by your diagonal element, which is Y12 plus Y23. So we know that all the parameter here, therefore we just continue the calculation. We find that V22 equal to 0.971057 minus J 0.043432. Okay, done for V2 for second iteration. Now we want to find V3 second iterations. Again, we know that we have to calculate the Q32. So Q32 is equal to minus imaginary part of these equations. So this equation, basically, we use the formula that we derived before. I think, yes, this one. So Qi k plus 1 equal to minus imaginary part Vi conjugate k times Vik Yii, your diagonal element, plus the summation of j equal to 1, j not equal to I for up to n bus for Yij times Vjk. Okay. So this is in the form of uppercase letter. Also the same you can use for the lowercase. I think if we have here. So basically this you can change to the emittance just because Y capital equal to minus Y lowercase. Okay. So basically both way you can use as long you know how to use this equation to find the Q. Okay. So back to example 2. So in example 2, Q32 second iterations. So we find that V31, why V31? Because this is second iterations. We already have the value for V31. So we have to use V31 times V31 times Y13 plus Y23 minus Y13 V1 minus Y23 V22. You cannot use this one because you already calculate V22 here. So you need to use this one to update Q32. Okay. So put back all the values. So you find that Q32 will be minus 38796. Okay. So this is what I could do. I found that the complex for Q3 equal to 2.16184 minus 1.387 I. Okay, so you just need to find the imaginary value. Okay, so use this to find VC32. So VC32, again, you use the power flow equation to find it. So VC32 equal to PC schedule minus JQ3 schedule divided by V3 conjugate for the first iterations. Okay, plus Y13 times V1 plus Y23 V2 second iteration, because you already find it before, and divided by Y13 plus Y23. Okay, so put all the parameters. Okay, so you find that VC32 equal to 1.03908 minus J0.0073. Okay, so done for VC3. This is complex. So since we know that V3 have the fixed value for the real part, which is 1.04, its magnitude. So only the imaginary part of VC3 second iteration is retained. For example, here VF32 is equal to minus 0.073 here. So we have to find the real part of VC3. So the real part is equal to square root of 1.04 square minus 0.073 square. So you find that E3 second iteration is equal to 1.039974. So therefore, you have the real part and also you have the imaginary part. So you finally you have the both V3 second iteration equal to 1.0399 minus J0.007. So this step keep on repeating, do the process until it converge with the accuracy of 5 times 10 minus 5. Okay, when it see the difference between two value, for example, V2, 6 and 7, it checks, it find that the accuracy of 5 times 10 minus 5, then it will stop. Okay, so this 1, 2, 3, 4, 5, 5 line here, value here, is just example. Okay, just example from third iteration to 7 iteration. So you can see that in third iterations, the value for V2 equal to 0.9707. So fourth iteration, it change, fifth keep changing, then change, and finally the value doesn't change, fixed only the this part also fixed, but for Q3 still change. Okay, still change, and V3 as well still change on the imaginary part. So it will continue check until it satisfies the accuracy 5 times 10 minus 5. Okay, so final solution based on the accuracy of 0.00005. So we find that V2 equal to 0.97168 with the angle minus 2.6948 degree. Okay. And your S3, so your S3 is equal to P3 plus JQ3. So P3 is fixed, 2.0. Okay, P3 fixed, 2.0. Okay, this fixed 2.0 per unit. But Q3 keep changing until it satisfies the tolerance or accuracy. So you get the value is 1.4617. Okay, 1.647. See, I'm not sure this is what iteration numbers, but if you look here and here, still doesn't seem right. 1.4608. This is 1.4617. Okay, so meaning that this value will keep on changing. Okay, keep on changing until it gets this value. And V3 after it converge, the magnitude is equal to 1.04 and angle minus 0.498. Okay, and S1, which is the apparent power at bus number 1, equal to P1 plus JQ1. How we get this value? So we use this equation to find P1 and Q1 or S1. So these equations come from these equations. Okay, Pi minus JQi. For instance, your bus 1, P1 minus JQ1 equal to, so this voltage going on to the left, to the right, become V1 conjugate times V1 times the summation of J equal to 0 to N Yij. So Yij. For instance, if you have bus 1, bus 2, bus 3, you have all the diagonal elements of 1, 0. If you have Y 1, 0 or 2, 0, 1, 0, you have to include 1, 0. So if you don't have, so you start with 1, 2, or 1, 3, because in previous example, we have two bus 2 and bus 3, one connected to bus 2, one connected to bus 3. So you have 1, 2, and 1, 3. Okay. So this example is already calculated for you, but you can check in at home whether you can find P1 equal to 2.1842 or and your Q1 equal to 1.4085. Okay. So once you got these solutions, these parameters, you can start find the S12, S13. Okay. But before that, you need to find the currents. Okay. You cannot straight away get to S12. You have to find, for example, I12. Okay, I12 equal to Y12 times V1 minus V2. Okay, because this step is already jumped into this step. But before you get the S12, you need to find current first. Once you get a current, you multiply with the voltage, then you find your S. Okay, like example, wait, like example, wait, example 1. Example 1. So you have to find I12, then you get S. So you find the current first. Get currents, multiply with the voltage, you get S12. Okay. So the line flow and the line losses are converted as follows. So line flow equal to S12 equal to your P12 and Q12. Okay. So you find S12, S21, S13, S31, and S23, S32. Okay. Then you get this value, you can find the line losses. So line losses, for example, SL12 is equal to S12 plus S21. SL13 equal to S13 plus S31. SL23 equal to S23 plus S32. So you get this value. Okay. So done for the line flow, line losses, all the S1, the apparent power for bus 1. So you can draw the power flow diagram. Okay. So this one I don't want to repeat, but it's same like example number 1. So all the parameter according to this value and this value. And don't forget that in this part you have a PV. So PV, your energy injected to the bus, while PQ, your power delivered out from the bus. Example, bus 2, you have P 400 and Q 250. Okay. And you have to put all the parameters, including the line losses. Okay. This is line losses. Okay. All right. So far, any question on example 2? Ada apa soalan untuk example 2? Before I present the exercise. Ada apa soalan? Okay, kalau tak ada, kita move on to exercise. Okay, so exercise, we have exercise 1, exercise 2. So you choose any specific. If you didn't choose, I choose for you. Okay. So if you do exercise number 1, okay. Okay, exercise number 1. All right. So in exercise number 1, figure 1 shows the single line diagram of 3 bus power system with generation at bus 1. Okay, so we have select bus here. So the voltage at bus 1 is fixed with V1 equal to 1.025 angle 0 per unit. Okay. So the schedule loads on bus 2 and bus 3 are marked on the diagram. Okay. And the line impedances are marked in per unit on a 100 MVA base. Line resistances and line charging substance are neglected. So in this case, you can see that the line doesn't have resistance value. Okay. And the line doesn't have a charging substance. Okay. So this I can say is a ideal case, very non-technical, meaning that in the real life you don't get this value. Normally you have some small value of resistance. Okay. So from this you need to use Gauss-Seidel method and with initial estimate of V2 equal to 1.0 and V3 1.3285 with the angle 19.8. Find V2 and V3. So I can say you need to find the phasor for V2 and V3, means your magnitude and your angles. Perform calculation for 2 iterations. So you need to find first iteration, second iteration, stop. Okay. B, after several iterations, the bus voltage converge to V2 equal to 0.9346 minus G 0.1159 and V3 equal to 0.97 to 4 minus G 0.0604. So maksud dia, dalam case B ni, it's already stated that after several iteration, meaning maybe after it's converged, when it finds the accuracy that required, so we find this two phasor value, V2 and V3. Okay. So with these two, V2, V3, and V1, okay, we have V1 here. You have to determine the line flow. Okay, S12, S13, S21, S31, S23, S32, okay, and losses. For example, SL12, SL13, SL23, and the slack bus real and reactive power, which is S1. S1 equal to P1 plus JQ1. Okay, you have to find for second questions here. Okay, so normally when you do the load flow calculation using any method, you start with develop the bus emitter matrix, or you find the emittances of the line, of the connection, any parameters to the ground, anything lah. For example, if you have a connection admittance to ground for bus 1, you have Y10. If you have connection to the ground, any impedance, you convert to admittance. Okay, so first find the admittance. So line impedance convert into admittance, because in this case the line are impedance. line impedance. So you convert into Y. So Y12 equal to 1 over J 0.05 equal to minus J20. So same goes for Y13 and Y23. You find its admittance. Okay. Done for first step. This is very basic step, but sometimes students still make mistake. Okay, because maybe they didn't read properly, or they didn't understand the question, or maybe they don't know how to read the figure. Okay. For example, the statement here, it already mentioned that it is a line impedances. But maybe you didn't read, you just take it as Y equal to J005. So it is totally wrong. So you need to convert into admittance first, because this is impedance. Okay. So once you get the admittance, you can start find the complex load that you convert into per units. Where is the complex loads? So in this question, both bus 2 and bus 3 is PQ bus or load bus. So there is a value for S2 and S3. Okay. So you need to convert it into per unit. Then only you can do the calculations. Okay. Because in calculation, you cannot mix actual value and per unit value. You need to change any actual value into per unit, then only you can start do the calculations. Okay. So therefore, change it into per unit. So S2 schedule. So this is your power at bus 2. You divide by 100. Why divide by 100? Because this is your S base. Okay. So this is your S base. So your S base is mentioned here is 100 MVA. Okay. So this is 100 MVA. So actual value divided by base value, you get per unit. So your per unit equal to minus 3.5 minus J 2.0. And don't forget, you need to put minus in front of this, because this is load. Okay, this is load. PQ. If in example 2 before, we have PV and PQ. So for PV, you don't have to put minus. But in this case, both are PQ. Okay, this is PQ. This is also PQ. Okay. So both you need to put minus. Okay, done for per unit value, both S2 and S3 schedule. Okay. So done admittance, done per unit for the loads. Then you can start doing your iteration calculations. Okay. So we have these equations. Okay, we have this equation. So what you need is, you need to know what is your initial value for V2 and V3. So these two already given in the equation here. Okay, or in this case from the from here. Okay, V2 is already given. All right. If the question didn't give the value, what you need to do? Okay, kalau dalam soalan you tidak diberikan ini, you tidak beri V2 0 and V3 0 tidak diberi. It just says find the solution for using Gauss-Seidel method, determine V2 and V3. So apa kita nak buat kalau dalam soalan tak diberi nilai initial value? Nilai apa kita nak letak? Nilai apa kita nak guna? Siapa boleh teka? Ataupun siapa boleh jawab? Nilai apa kita nak pakai untuk V2 0 and V3 0 if in the question it didn't give the initial value. It didn't state anything regarding the initial value for V2 and V3. So kita nak pakai nilai apa? Ada siapa-siapa nak cuba? Ni ada tak ada depan komputer ni? Depan handphone? Saya takkan ulang pandai-pandai nanti you baca nota tu.
Ada doktor.
Apa nilai dia? Agak-agak apa nilai nak letak tu? Okay. So kalau you baca betul-betul nota yang sebelum ini, lecture yang sebelum ini, dia dah mention nilai dia adalah 1 plus J0. Okay, ada di stated dekat dalam nota sebelum ini. Okay. Okay. So it said that thus for Gauss-Seidel method, an initial voltage estimate of 1 plus J0 for unknown voltage is satisfactory and the conversion correlates with the actual operating state. So meaning that you can start with 1 plus J0. You boleh mula dengan 1 plus J0. Okay. Tetapi dalam soalan ni, dia tak begitu. Okay. Sebab dalam soalan ni, dia dah bagi nilai V20 and V30. So you kena pakai nilai ni. You tak boleh pandai-pandai letak V2 equal to 1 plus J0. Okay. Okay, so you already have V20, V30 and V10. Okay. So V2 first iteration equal to P2 schedule minus JQ2 schedule divided by V2 conjugate 0 plus Y12 times V1 plus Y23 times V3. Okay. Divided by Y12 plus Y23. Okay. So put back all the value for V1, V2, Y12, Y23, P2, Q2, Y12 and Y23. You find that V2 first iteration is equal to 1.0875 plus J0.1375. Okay. So I want to remind you all, in any test, for example, you didn't get this equation. You need to know how to produce this equation. But normally in the test, we only provide you the general basic equation to find what is V2 first iteration. For example, you have in the previous slide, okay, in the previous lectures, you have this equation. Okay, so we only provide you this equation. So you need to solve for what is V12, for instance. Okay. So you need to know how to produce these equations. Then once you get this value, so you continue with V3, bus number 3. Okay. So V31 equal to P3 schedule minus JQ3 schedule divided by V30 plus Y13 times V1 plus Y23 V2 first iterations. So first iterations, you got it from here. You move to here, divided by y13 plus y23. Okay, so put back all the value, all the voltage value, admittance value, power, and reactive powers. Then you find that V31 equal to 1.0278 minus J 0.000138. Okay, done for first iterations, bus voltage at bus 2 and voltage at bus 3. Okay, so now continue with second iterations. So once you get the value for V21 and V31, you need to use it to calculate for V22. So in V22 is equal to P2 schedule minus JQ2 schedule divided by V2 conjugate using first iteration value, which is this one. Put it here, plus Y12 times V1 plus Y23 times V3 first iteration value divided by Y12 plus Y23. Okay, so finally you find that V22 is equal to 0.9912 minus J 0.0850. Done for V2 second iterations. So continue with bus 3, V3, what is for second iterations? So V3 second iterations equal to P3 schedule minus JQ3 schedule divided by V3 conjugate 1. Okay, meaning that you use back the value from first iteration, this value, okay, put into this to find second iterations. So plus y13 times v1 plus y23 times v2 second iterations. Why you didn't use first iteration? Because you already have the second iterations. The second iteration you need to put into here to find v3 too. And then you divide it by your diagonal element, which is y13 plus y23. Diagonal element for that belong to bus 3, at bus 3. So put all the parameters, the values for voltages and also admittance and power, reactive power. You find that V32 equal to 0.9891 minus J 0.0533. Okay, so done for question B. Okay, done for question, because it just asks you to do 2 iterations. Okay, stop, continue, question B. In question B, it gives you the value V2 and V3. Okay, so you use this value, find line flow and losses and the S1, which is real and reactive power. Okay, so B. So from these two value as well as V1 equal to 1.025 angle 0, find the current first. Okay, so the step is like this. Once you want to calculate the line flow and line losses, you need to find the currents because you already find the voltage. You find the currents. So in this case, for I12, your admittance value Y12 times V1 minus V2, you got the current for I12. So I12 for I21 is equal to minus I12. So you get the value for I21. Same goes, you need to calculate for 13 and 131, 123 and 132. Okay, done for currents. So once you get the current, you can find the S because S equal to VI. So for instance, S12, the line flow S12 is V1 times currents 12 because your S12. So start with 1 because at S1, so V1 times I12. Got the value in per unit. This in per unit, you multiply with your base value 100 MVA, you find the actual value. Okay, continue with S21. S21 is equal to V2 times I21 because S2 V2 you have line between line 1, bus 1 and bus 2 and bus 1, use I21. Okay, so you get the value for per unit, convert into actual value. Okay, so repeat the same procedure, same step, do for next S, which is S13, S31, and bus for bus 23 and bus 32. Okay, you find all the six line flow. Because you have a 6 bus, you have 6 line flow, because all the bus are connected. Okay, all connected together. So once you get the line flow, so the next step will be much easy, because you want to find the line losses. So the line losses equal to SL12 equal to S12 plus S21. Okay, so put back the value that previously you calculate, this 12 and 21, you find that the SL12 0 megawatt plus J43.21 MVAR. Okay, so repeat for SL13 and SL23. So if you look here, you find that there is a zero line losses regarding to power, real power. But for reactive power, yes, you have. This is because this circuit, it has zero line resistance. The line resistance is already neglected. That's why you didn't have P, you only have Q. Okay, sorry, you only have Q because you have reactance here. Okay, and the flow of the reactive powers. Okay, so done for that, SL12, SL13, and SL23. And finally, you need to find the slack bus real and reactive power. So for the real power, P, and reactive power, Q. So using the equation that I showed you before, so P1 minus JQ1 equal to V1 conjugate times V1 times Y12 plus Y13 minus Y12 times V2 plus Y13 times V3. So put all the parameters, the values, you find that P equal to 6.5, Q equal to 5.4 for something. Okay, so this value in per unit. So you need to convert into actual value. What is the actual value? So finally, P1 equal to 650.33 and Q1 equal to 544.75. All right. So done for both question A and B. So in this question, it doesn't ask you to draw the power flow. So if it doesn't show us, you don't do it. Okay. In the test, if you didn't ask, you don't show it, or you didn't do, because it will take time, and you will be lost many times. You can use that time for checking your answers. Okay. So so far, any question on exercise 1? So I think we done for example 2, and today I show you exercise 1, the solutions. Okay, so far any questions? Ada apa-apa soalan?
No, sir.
Okay, kalau tak ada soalan, sila ambil kedatangan. Kalau ada yang tidak dapat ambil, sila bagi tahu segera, sebab saya tak mahu bila dah I dah close, ada orang mesej saya tak boleh itulah, tak boleh inilah, so I takkan ambil kira lah. Lepas tu saya assume dia tak hadir kelas hari ni. Okay, so untuk grup sebelum ni pun saya dah mention dah, kalau selepas ni kalau online, katakan you tak boleh, bagi tahu masa kelas kata tak boleh, dan saya take note, saya akan tolong key in dalam you punya attendance lah. Okay, alright. Kalau tidak ada apa-apa, semua dah ambil attendance, kita stop hari ni dekat sini. So kita akan continue pada selepas cuti raya. Kita akan buat tutorial dan kita sambung dengan interruption method untuk solve power flow. And please do tutorial question number 1 to number 3. I think that covers up to Gauss-Seidel method. Okay, and we will discuss it on the first week after the Hari Raya. Okay, so thank you so much. Selamat Hari Raya pada pelajar yang bukan Islam dan pada pelajar bukan Islam. Selamat bercuti. So please take care. See you after Raya. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Sama-sama.
Assalamualaikum.
Selamat Raya, sir.
Selamat Raya, Mak Zaibatin.
Selamat Raya, sir.
Selamat Raya. Jumpa lagi.
Selamat Hari Raya, sir.
Selamat Hari Raya.
Selamat Hari Raya, sir.
Selamat Hari Raya, maaf Zahir batin. Ya, you're welcome.